So unit number 7 is where we focus on functions and their operations. So operations are definitely adding, subtracting, multiplying, dividing. But in addition to that, there are two unique operations that go with a function. That's called composition and the inverse. Composition and inverse we won't get to till next week. But we will start with the basics of a function today. So, as it relates to a function, in your case, you can see everything? Okay. All right, so when we work with a function, the standard notation of a function is f parentheses x. F parentheses x. So the f is the name of the function. The letter in front of the parentheses is the name of the function. The letter inside the parentheses is the variable that you should see. So, I have two examples. F of x equals 3 plus 2x. G of x equals x squared minus 2x plus 3. Again, the letter outside the parentheses is the name of the function. The letter inside the parentheses is the variable that you should see in the function. So, how does that help us? It helps identify what we're going to do with the problem. Helps identify what we're going to do with the problem. So, as far as today goes, we're going to do some simple working mathematical work with regards to a function. Simple mathematical work with regards to a function. So let's start with basic evaluating of a function. So find the value of f of negative 3 given 2x squared plus 3x minus 5. So f of negative 3 means plug negative 3 into the f function. Plug negative 3 into the f function. F of negative 3 means that x is equal to negative 3. Plug it in. X is equal to negative 3. Plug it in. So when we solve this out, this is 2 times negative 3 squared plus 3 times negative 3 minus 5. So we only have to plug it into the right-hand side. We don't have to worry about the left-hand side. Any questions before we continue? Good? So now we work the problem out. We work the problem out using order of operations. So remember order of operations. So we have parentheses in your exponents, multiply or divide from left to right. Add or subtract from left to right. So, order of operations still applies. So you have negative 3 inside the parentheses. There's nothing to solve out, so we keep going. Negative 3 squared, remember, negative 3 squared is negative 3 times negative 3, which is 9. 2 times 9 plus 3 times negative 3 minus 5. Again, there's interference in that part of the board. That's why it's all squiggly. So then it becomes doing the computation. 2 times 9, 18. 3 times -3 is -9, minus 5. 18 minus 9 is 9. 9 minus 5 is 4. So your final answer is 4. So, not hard. It's just another way of setting up a problem that you all have worked out before. Any questions before we continue? Sure, you're done. Yeah. All right. So example 2. So again, those of you who are remote right now, if you have questions, either come off mute and ask or type them in the chat. Again, hybrid student has an advantage because they can directly ask me whatever question they want. You have to speak up so that I know what you're talking about. All right, so example 2. If g of x equals x squared plus 5, evaluate g parentheses x plus 4. So remember, g is the name of the function, x is the variable we're supposed to see, x squared plus 5 is the actual function. So when they say g of x plus 4, this means plug x plus 4 in the variable, in for x. So we're going to take x plus 4 and plug it in for x. We're going to take x plus 4 and we're going to plug it in right there for x. So this is what it should look like. So instead of x squared plus 5, it's going to become x plus 4 squared plus 5. So it's the same thing as plugging in a number. It's the same exact thing as plugging in a number, except there's still a variable in there. That's okay. That's going to happen. Any questions before we continue? Any questions before we move on? Chat. All right, so before we start, so as we start working this problem out, here's the way that most people get this problem wrong. Here's the way that most people get this problem wrong. They're going to see x plus 4 squared and then do x squared plus 4 squared, x squared plus 16. That's the wrong with you. That's the wrong with you. So if you're guilty of that, that's fine. Now let's learn. Now let's do it the right way. X plus 4 squared means x plus 4 times x plus 4. So that means we're either going to be doing FOIL or the Punnett squares if you're a person that likes the Punnett squares. So now let's solve this out the right way. X plus 4 squared is x plus 4 times x plus 4. So remember, if you have questions, make sure you ask. If you have questions, Liana, Mahalia, Fernando, Mariah, if you have questions, make sure you ask. So if we're doing FOIL, x times x, x squared, x times 4, 4x, 4 times x, 4x, 4 times 4, 16. So yes, you have to write it twice and you have to do FOIL. I'm not having you do it that way to make you do more work. I'm having you do it that way so that you get it right. My concern is that you get it right. So now we got all these variables running around here. Combine our like terms. So x squared, 4x and 4x, 8x, 16 and 5, 21. So x squared plus 8x plus 21. There it is, problem go. So again, example 2 is just like example 1, just has variables. I'll be looking at you. Question on example 2. All right, so example 3. So example 3, a little bit more of an application. Find the value of A such that f of 4 equals negative 19, given f of x equals ax squared minus 5x minus 7. So, remember, f is the name, x is the variable, the part on the right-hand side is the actual function. So, when they say that f of 4 is equal to negative 19, what that means is if you plug in x equals 4, negative 19 is the answer. So if you plug in x equals 4, negative 19 is the answer. So this is how we would set up the problem. If you take negative 4 and plug it into that would be a parentheses a parentheses 4 squared minus 5 times 4 minus 7. If you plug 4 into that, your answer is negative 19. That's what this little statement up here is saying. That's what that statement is saying. That's what the statement is saying. Any questions on how that is supposed to be interpreted? So if you can interpret that correctly, you can solve the rest of the problem. If you interpret that part correctly, you'll be able to solve the rest of the problem. You sure you're good? All right. So let's solve this out a little bit. 4 squared we can work out. That's easy. 4 squared, 4 times 4, 16. Negative 5 times 4, simple. negative 20. Minus 7 equals negative 19. If you notice, this is an algebra 1 problem now. It done reduced itself down to an algebra 1 problem. Negative 20 minus 7, negative 27. So we're back to a relatively easy problem. Add 27 to both sides. 16a equals 27 minus 19 is 8. Divide both sides by 16. 8 over 16 is 0.5. But that's also the fraction 1/2. That's also the fraction 1/2. That's also your fraction 1/2. Oh. So, you get 0.5 or 1/2. I personally don't care which one you get, as long as the work matches the answer. So, for example 3, where it tells you how, substitute the given value for x and the function value into the problem, and then solve for a. So, the explanation of this first part is very, very important, because that part tells you pretty much how to set up the problem. That part pretty much tells you how to set up the problem. Any questions? Example 3. We'll give you a moment to, those of you who are at home, give you a moment to finish typing it out. It just feels better having someone in the classroom. Good. I've been doing this since August by myself.
I don't go to school, I don't learn. I ain't talking to you.
Well, welcome back, man. It's gonna get easier now.
Yeah, I hope so.
All right. So let's do example 4. Then we'll go back and do an example of any of the other ones that you feel that you may need to see another one. So find the value or values of x such that h of x equals x squared minus 3x minus 10 will equal 0. So they want to know, when will this function equal 0? So take the function itself and set it equal to 0. Take the function itself, set it equal to 0. So think back to what we did in unit number 5. So if you just have an x, then that's a linear equation, and that's pretty easy to solve. If you have x squared in the problem, that means you're either going to be doing factoring or square roots or quadratic formula. Now, we don't want to do quadratic formula unless we absolutely have to. So let's see if we can factor this. So you have 1, 2, 3 terms. So 3 terms means MAF. So this is an MAF problem. A is equal to 1, remember A is in front of x squared. B is equal to -3. B is in front of x. C is equal to -10. C has no variable. C has no variable. Let's change this to our MAF problem. So for M, you multiply A times C. So 1 times -10 is -10. A is just rewriting the B value. It's -3. So as for the numbers, we need two numbers that multiply to -10 and add up to -3. Multiplies to -10, adds up to -3. Give you a quick second to think about it. So, say that again, I'm sorry. Alright? +2. So, -5 times 2 is -10. -5 plus 2 is -3. Always divide by the A value. But if you divide by 1, nothing changes. So that means your factored form is x minus 5 and x plus 2 equals 0. Let me give a moment for some folks to catch up. Anyone with any questions before we continue? We're not done. All we've done is factor it. All we've done is factor it. Remember, this said find the values of x, so that means we need actual numbers. So now let's solve it out. Take each factor, set it equal to 0. So take each part, set it equal to 0. Finish that already. You finished it already? Mm-hmm. Oh, let's see what you got. Oh, okay. Oh, you still have it. All right. So we take each factor, set it equal to 0, and now we solve each part. So for x minus 5 equals 0, add 5 to both sides. Subtract 2 on both sides. X equals -2. So those are your two answers for example number 4. So sometimes a problem like that will have two answers. Sometimes a problem like that will only have one. So don't get discouraged if you come across a problem in which there's only one answer for it. As long as you did the math right, then you're good to go. Any questions? Example 4. Any questions? Example 4. All right. So what I want you to take a moment to do, look back at examples 1, 2, 3, or 4. If there's any particular example that you want to see another example of, now's the time to let me know that so we can do another example. So an example of plugging in a number, an example of plugging in another expression, an example of finding an A value, or an example of setting it equal to 0. So you know that there's one that you would feel more comfortable seeing another example of, let's let that be known now so that we can do another example. So I'll give you a moment to look if you need to look back at your notes. All right, go ahead. Okay. Let's see, is there a particular one you want to know one on?
No, not right now.
Okay, so George.
Mm-hmm.
Okay. So Shay, which one did you say you wanted another example of? Okay. Example. So do you want this one with factoring or it doesn't matter? All right. So let's do one with factoring. So I'm on the same notes page, and we're going to use this function here. Q of x equals x squared plus x minus 6. And we're actually doing example 6c. Find the values of x such that q of x equals 0. So the first thing we would do is to take the function. Take the function and set it equal to 0. So that would be the first thing we would do. Take the function, set it equal to 0. So again, remember, if it's just x, then that's linear and we can start solving immediately. If it's x squared, then we're either using factoring, square roots, or quadratic formula. So this is one in which we could factor. So we'll get our a value. So a is in front of x squared, so that's 1. B is in front of x, so that's 1. C is the number with no variable, that's negative 6. Let's turn it around and make it MAF. To get M, you multiply A and C. 1 times negative 6 is negative 6. The A value is simply B moved over. So we need two numbers that multiply to negative 6 and add to 1. Two numbers that multiply to negative 6 and add to 1. Anyone got those? I think they might have them.
Three times negative 2.
3 times negative. 3 times negative. I heard 3 times negative 2. Anyone else got 3 times negative 2? So, yeah, I can agree with those. 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So those are valid. Take the A value and divide it out. 3 divided by 1 is still 3. Negative 2 divided by 1 is still negative 2. That gives us x plus 3 and x minus 2 equals 0. So, Sherry, we good so far? Finish off this problem. Now we take the 2 parentheses, set them equal to 0. Subtract 3. of our two answers. Add 2, x equals 2. That's the other answer. So, remember, like I said, not every single one of these problems is going to have two answers. If you're going to factor it, then you should expect to have two answers. If you don't have to factor it, then you're not going to have two answers. You'll probably just have one. Probably just have one. Was there another one that you needed to see, or were you?
Can you do the FOIL again?
Sure. 6B ward. All right, so we're going to do another example. We still got 10 minutes in class, so we're good. So we're going to do another example like example number 2. We're going to do another example like example number 2. So we're still going to use the same function. We're going to find q of x plus 2. So find q of x plus 2. So that means we're going to take x plus 2 and we're going to plug it in for x. So notice that it's in two different places, so we got to plug it into two different places. So x squared plus x minus 6. Everywhere we see x, we're going to replace it with x plus 2. Everywhere we see x, we're going to plug in x plus 2. So that means we have x plus 2 squared plus x plus 2 minus 6. Everywhere we saw x plus 2, everywhere we saw x, we replaced it with x plus 2. So now we're going to solve. All right, so Jonathan, this is where the FOIL comes in. If you see a parentheses raised to the second power, go ahead and write it twice. So bring everything else down. That way you don't forget about it. So now we're going to do FOIL. So x times x is where you get your x squared from. X times 2 gives you your 2x. 2 times x gives you 2x. And then 2 times 2 gives you your 4. So, good so far?
Yeah.
So that takes care of our FOIL. With this second parentheses, remember that there's no number in front, understood to be 1. So we're going to distribute the 1. 1 times x is 1x. 1 times 2 is 2. And then minus 6. So now all that's left is to combine all of our like terms. So x squared stays x squared. 2x plus 2x plus x is 5x. 4 plus 2 is 6. 6 minus 6, well, that's 0. So that's your final answer. So anytime you have something squared, that means write it 2 times and then multiply it. it 2 times, then multiply that. So we did 6B. Any other questions? Questions on or additional examples needed? So we've done 2 examples of example 4. We only did 1 example of example 3, so I'm assuming people are pretty okay with that. We did 2 examples of example 2, and we did 1 example of example 1. That one's pretty simple, you're just plugging in. Any questions before we look at the homework assignment that goes with this section? All right, so let's take a look at the homework that goes with this particular section. So I'm going back to where the stream of your Google Classroom. I will post this to the classwork section after this class is over. So all the homework for this unit has already been posted. So we're going to look at just this first page. So the first page, it says functions review worksheet. This is basically what we did in class today. So problems 2 through 7, you're given a number and you're plugging it into the problem. So to help you, off to the side, on the left-hand side is an example of that type of problem. So for example, with number 2, f of 24 means take 24, plug it in for x. So that's 24 divided by 2, and that's 12. And you work similarly with the rest of the problem there. So the second set, instead of a number, it's a variable. So there's one example that's done for you. So this gives you another example of the FOIL, just in case you needed the additional example. And then you have 6 problems that will work with that. So one hint that I will give you is that problem 9 will use FOIL. Problem 9 will definitely use the FOIL. Alright, the second part, find the value of the indicated variable. So this is actually to find b, if f of 5 equals 73. So this is like example 3 from the notes. Plug 5 in, and then set the function equal to 73, and then solve out the rest of the problem. So everything there is pretty self-explanatory from there. And then the bottom part, find the values of x that would give you f of x equal to 0. So that means take the function, set it equal to 0, and solve it. So the example I gave you is an example of factoring. So pretty much every problem is going to use factoring except for problem 20. So 20, there's no factoring for it. 21, 22, 23, and 24 are factoring. 25, you can either factor it or you can solve it using square roots. So there's two ways that you could actually do prime 25. Now, if you don't like factoring at all, any factoring problem, you can also use quadratic formula. So just know that any factoring problem, if you absolutely just do not want to use it, or do not want to do it that way, can be solved using quadratic formula. Just know quadratic formula is this thing right there. So there's the quadratic formula. If you want to solve it using the formula, that's your right if you don't want to factor it. But that means you have to know how to do the quadratic formula too. So that's on you with that one. So just because the homework is not due until March 15th doesn't mean you have to wait till the last minute. If you finish the assignment, upload the assignment to where it is on Google Classroom. There's no reason for you to wait. I will post the answers so that you can check your work as you go along, make sure you're on the right track. But yeah, don't procrastinate with it. If you finish it early, turn it in early. That way, that's less for you to have to worry about. Any questions before we wrap things up?